Hi, everyone. My name is Davies. I'm working in Berlin for Immobilien Scouts. I'm talking to you today about the paging library with the Jetpack. So apps are basically lists. Most of our applications are designed in such a way to display lists of data, lists of structured data in sort of a feed form. Think about any social media app that you've ever used, Facebook, Twitter, Reddit, all these things. It's all just structured lists of data. And this might seem quite simple at face value, but it's actually a lot of hidden complexities. And it was actually quite difficult to find safe for work screenshots of these apps. So what are the challenges that face us when we build these sort of paging applications? Because the presentation of feed content isn't so simple. And we need to make sure we are seamlessly delivering structured content in a personalized and efficient way. So we want to make sure that the data is up to date. The user is seeing the latest content. And then this can be achieved either by polling for data or receiving push notifications. And how do you animate these content changes for delivery? And you calculate the difference in making sure to happen in the background so you're not affecting the UI thread. How do you handle large data sets? Because there's a lot of data that to be displayed often. Should you be streaming content or load data in snapshot chunks? And ensuring that these large amounts of data don't sit in the memory for too long, as it can slow down the performance of the device. Additionally, how to handle offline. I mean, a lot of people have difficulty with network connections, or if you go in the underground, or you just live in an urban area, or you live in Germany, where we don't have very good internet. So basically, the abundance of network connectivity shouldn't be assumed. And how to properly display to users statefulness. So, give accurate feedback of what your app is currently doing. This isn't limited to architecture, but it's more like how to convey the state of your application, whether you're loading or whether there's an error occurred. Just useful information to show to your users. And furthermore, on the loading topic, how to actually properly show progress. So kind of make sure the user doesn't get frustrated because of waiting for things to happen. And there are a lot of different loading state animations available we can use. We can have progress bars, you can have placeholders, and then you have to make sure that you're selecting the right option that fits your application. So let's do a bit of history, and like how was this implemented on Android previously? What options did we have available to us prior to getting Jetpack? So the de facto solution was often a list view. Now this was available from the Android API version 1, and this was basically the only way we had of displaying data. It was designed to display a vertically scrollable collection of views, basically. And then we'd attach this with an array adapter, and in most cases it was sufficient to use an array adapter if you've got like a list of strings. And this would extend the base adapter, providing a filtering comparator for strings. Quite simple to set up, but very limited in capacity. If you needed a more complex type, then you'd have to extend base adapter yourself. You'd have to provide appropriate filtering and actually do a lot of the boilerplate implementation yourself, which was quite tedious. But you've got both the inflation and the binding of the view in the same kind of behavior, and then handling the item data set as well. So then you'd have to actually not only handle the data dataset, you'd have to actually notify the changes that have occurred. And you would only be able to notify the entire dataset as invalidated. So this would often result in a very expensive reload of the UI logic behavior. So there's no support for data range invalidation or diffing. So how would we handle pagination in that respect? Or like how would we achieve like an infinite scrolling list view? I mean, many solutions would actually opt for having like a next or previous pagination button at the bottom, but it could be achieved with a scroll listener. So you'd have a scroll listener that would listen for scroll events, and as you're approaching the bottom of the list, you then fetch more data, invalidate your entire data set, and then make sure your user is seeing the new data. So, I mean, it's not ideal, really. It's actually quite terrible. So let's review that. So base adapter and list view. We've got managing lists of its own data, manages view inflation and configuration, it notifies the entire data set of change, so it invalidates everything, and it's not capable of diffing any items, so you can't do a partial dataset change. So, introducing the recycler view. This was introduced with the support library in April 2015. It was independent of the Android platform, so you could backport it to older versions of Android. I think though Android X requires API version 28, there are previous artifacts if you are unlucky enough to target an API version lower than that. So it's sort of a more advanced version of the list view, a bit more kind of simplicity in its behavior. It's like a minimal implementation, focused primarily on recycling views, the clues in the name. But it's much more efficient. It doesn't have to handle all these kind of extra additional behaviors. So like when you had a non-click listener that would be available on list view, this is now handled manually. And you still have to kind of manage items like this. And I think there was also the item decoration introduced, which you would use to achieve item boundaries. So then, many early paging attempts achieved with the cursor and to load chunks like this, and it was sort of like live streaming from a database. I didn't really have much capacity for invalidation of previous data. So if you had, you loaded like the first 10 items, and then you paged lower, and then suddenly one of those previous items is removed for some reason, you get a crash. But avoid querying on the UI thread, keep memory overhead low. It's optimized for low memory usage, raw cursor access, but it struggles with large data sets. There's a nice little comment from Chet Haas on the ADB backstage where they say, well, the solution to this is just don't have large data sets, which doesn't quite work. So yeah, there's no way of managing data invalidation for previously loaded items. So unlike the list view, the recycler view allows for more granular control of item invalidation. You can actually specify that there has been a data range changed, and then it will handle the animation appropriately. So it's possible to invalidate specific items and animate accordingly. The diff util and the async counterpart, the async list differ, was introduced in the support library in December 2016. If you're interested in how the diff util actually works, gets a little bit complicated, but it's quite interesting. It uses the Myers diff algorithm. Now, there's a nice article from Adrian, it's linked at the bottom here, which explains how this algorithm works. I recommend giving it a read, but it's not necessary to understand how recycler view and the paging library works. So a little bit after this, we had the list adapter introduced. And this came to us in the support library in February 2018. So just a few months before Jetpack paging was actually announced. So you can sort of see the direction that the development team are moving in here, and the way that this handles items collection and things for you. It's actually a very fundamental bridge in migration to using the paging library. So most importantly, it introduces the concept of immutability. It utilizes all the existing strengths of recycler view, computes diffs in the background with animated updates, and it makes, as I said, it has immutable lists, which means you have to submit an entire list in one go. Now, you might think that is computationally expensive or an ineffective use of memory, but you have to remember that the recycler view is handling diff changes properly in the background. So this is handled on the background thread, so it's not affecting your UI, and then the changes in the UI will then be animated accordingly. So yeah, you'd have the submit list. This achieves immutability by taking control of the list away from your implementation. So you no longer have to kind of worry about storing your data in the adapter or how this is kind of stored or effectively used. And you can just focus generally on the view creation and the view binding behavior instead. So, migration. So since the list adapter plays such an important role as the precursor or post-cursor to the paging library, it's generally a good idea to use it wherever possible. And if you're not already using it, I recommend picking it up and taking a look. Even if you don't need to use paging, it's just a good idea to use this adapter. But how would that migration look like if we're already using the recycler view adapter? So this is a sort of naive implementation of what a recycler view adapter might look like. It's already assuming a lot about your infrastructure and implementation, but it's can be assumed that a lot of implementations are quite similar to this. We're already using the diff util here to dispatch updates on updating lists to make sure that these are happening in the background thread and animated accordingly. And a diff util callback might look something like this. It's very simple. You're just getting the old and new list sizes. You're comparing these two items and calling our items the same and our contents the same. The difference between I'll explain in a second. So since the list adapter is going to take care of our item management, we no longer need to extend the diffutil callback. We rather want to extend the diffutil item callback to actually perform the comparison functions, which means our implementation shrinks down to something a little bit closer to this. In most cases, because we're not actually storing any values here, we can actually use an object. So it's a bit better to use, a bit user-friendly from this perspective. We're only performing two comparison operations. We're instructing the adapter on the equality of our items so that it can apply the algorithm, as I mentioned, the myasdiff, to recalculate the difference in the two data sets and give us buttery smooth animations that our users love so much. So the two behaviors here are our items the same and our contents the same. Null is assumed to be the same as null, and a non-null value is not expected to be different from a null value. Our content's the same, is only called if our items are the same, returns true for both items. And the reason for this is that our items are the same is that you can compare the ID of the items. So is it kind of intrinsically the same data concept, but then you might want to change the binding behavior, say if you've got a selected state or something. So now we're going to go to our diffutil callback. Let's go back to our recycle view. Adapter, sorry. And we'll want to then now extend the list adapter. In the list adapter, you have to kind of provide the parameterization for your view type and your view holder and pass in the item comparison. Now, as mentioned, it's an object, so we can just pass it in without having to instantiate it quite easily. And now we've got a list adapter and it's handling list items itself. We no longer need to worry about having items. So we're only really concerned about the behaviors like on binding and on creating view holders and the actual view holder itself. So the implementation looks a bit more like this without those items there. And you just retrieve the items via the get items, which is incorrectly labeled here as an array. So we can now drop all that behavior and just rely purely on the list adapter. The implementation is much more simple and lightweight, and I'm allowing the list adapter to do a lot of the heavy lifting instead. So yeah, it already makes a lot of sense to use a list adapter wherever possible. Migration is fairly straightforward from the existing recycler view, and it makes moving to the paging library much simpler and much easier to use. So let's quickly review Jetpack and the paging library. So last year, Google introduced us to the Android Jetpack. It was dedicated to help us bootstrap applications and getting us going quickly with Android development. It was sort of an opinionated and clean implementation from the Google team for a lot of common problems, and introduces these ideas that Android developers have been begging for architectural hints for years, and there's never really been an opinion given. It's just we only care about your activity. And that's your entry point. After that, your architecture is up to you. But here's Jetpack introduces some examples and some sort of guiding tools for new developers. So it's built on four concepts. The foundation components, so these are the KTX helpers, multidexing, and security. You've got the architecture components, so LiveData and viewModel, navigation, paging, and room persistence. These two are quite important. We have behavior components, so like media playback, notification permissions, and slices. This is also the correct way of spelling behavior, thank you. And finally, Jetpack UI components, so like fragments, transitions, animations, and emojis. So the paging library, and I'm very aware that this is like 43 slides in, and I've not yet actually told you about the paging library. So let's get started on that. Like a lot of the Jetpack components, the paging library is built from 3 or 4 fundamental parts. It has the PagedList adapter as an adapter to present loaded data and manage diffing. We've got the PagedList, which implements a list to manage the loading of data from a data source. Gets quite complex in the implementation, but just don't worry about that. The DataSource and DataSource factory, base classes for loading data with relevant subclasses, and the BoundaryCallback to signal when a page list has been reached and the end of available data, so you need to then fetch more data, the same as you would with the on-scroll listener, as I mentioned with the list view earlier. So if you take a look at the code lab, you'll see the assumed architecture of your application, making many uses of existing Jetpack components like LiveData and viewModel, most notably the viewModel between the UI and repository in the database. So let's go through it step by step. So you have your UI, your view model, your repository, and assume database. Let's not worry about the implementation, just as a concept overview. We'll assume the usage of live data here, so we can have observability that is lifecycle aware between our different layers. And ensuring the data is not actually being loaded or manipulated if the user is not actually looking at the screen. So it saves a lot of battery power there. This also works for any sort of observable components, so you can do the same with Rx, but for the sake of simplicity here, let's just stick with live data. So the paging library introduced the concept of page lists. So we changed our list implementation to a page list. Now this is a page list is sort of just a lists implementing interface that is capable of loading data snapshots and provide the repository with a builder that can produce it with live data. So we add the data elements from paging to retrieve the data. This can be back from a room source, or you can actually roll one yourself. But you're managing you can manage a single source of truth via a database. That's a recommended use case, but you might not have the same use case. Maybe you have a network only, or you just want to use database only. But then you'll use the boundary callback to indicate the data required. And if you compare this to the image on the code lab, you can actually see the implementation interfaces and how these interact with each other. So it's a little bit clearer on these individual components, and hopefully this explains everything you need to know about the paging library, or not. A bit too fast. So let's quickly review that, and let's take a look at it a bit slower. So displaying lists of data will generally require you to traverse through a lot of different layers of your application. You'll need to kind of go through your entire stack, which means going from your database to your repository, to your interactors, use cases, however you have your application architected, would mean you have to transcend all these different layers, all the way up to your activity if necessary. So by using live data extensively, we can ensure that data is only loaded when the user is looking at the screen. Data changes are lifecycle aware. So you can make sure that your app behaves as expected. You're not going to get any unexpected crashes or unexpected behavior. Like I said, this also works with a lot of other observable types like RxJava or Flow. But you have to make sure to handle the lifecycle events yourself. This is another topic. So one of the first steps in migration is the integration of PagedList. And the PagedList is propagated through our hierarchy of the UI via LiveData. But what is this PagedList, and where's the data coming from? How is it building this data? It seems like a black box of magic at the moment. So it's basically, fundamentally, a PagedList is a pretty complex, lazy loading list. And thankfully, that complexity is hidden behind the implementation, but it's capable of loading data snapshots on demand and as is necessary while you're paging through the lists. But all you need to know is that it implements a list, and you can pass it as such. So extending the list, it's able to retrieve potentially infinite list of data. It manages execution and executors, doing scheduling for asynchronicity, and preparing data from a data source. It's not necessary to understand how it works. It's actually quite a lot of logic piled into one implementation interface implementation. So you just need to all you need to know really is that it's a lazy loading list. And that's how it's handled. But we still need to build this. We still need to provide it with the data that it needs and the components and the configuration that it needs for your application. So we cannot directly instantiate it. We have to use the builder. This ensures that the data is up to date and relevant. With data sources and cache management, you have a page size and prefetch distance to make sure you can load as much data as you need in one chunk. Maybe you might need to do some prefetching before if you've got poor network conditions or a poorly designed API. How to handle offline behavior, cache invalidation, and managing this behavior to actually display properly to the user, and what UX behavior to display whilst loading. So got sort of three options when it comes to these. And each specific is a container type, and it's sort of built for your implementation type. So you've got LiveData page list builder, quite a mouthful. This is for LiveData. I know it's the default implementation for Room. You've got the Rx page list builder. If you want to use observable types from RxJava, you can actually return an observable and a flowable, whatever's necessary. And there's also another option, which is unofficial, but I quite like it myself. It's the Flow page list builder. This is for use with coroutines and the experimental flow. This is not actually in Jetpack, but it's on Chris Bain's TV application, and so you can find that on GitHub. The link's at the bottom. The slides will be at the end as well, so you can check links if you didn't catch them at all. So let's just go with the LiveData page list builder. Let's just assume the usage, because they generally all do the same thing. They all have the same interface, but they just produce different types of artifacts. This is the default for Room, LiveData, so let's continue using this one. And let's go into our repository. So let's take a repository returning a page list. It's not so important where you build your page list. It can be in your view model, in your repository, in use case, fragment, or activity. This isn't a talk about architecture. It's about your best judgment here and how to use the paging library. But it seems that there's a really long hierarchy of things to build here, because in order to build a page list, you need a page list builder. And in order to build a page list builder, you need to build a DataSource factory. Now, we're already building a page list. Like, why do we need this? Like, how do we build this now? It's getting a bit ridiculous. So there is a bit of hierarchy, but let's just kind of assume that we can get a DataSource for now, and we can get back to that. So we're getting a DataSource factory from our user service. Let's just assume that's the case for now. And we build the live page list builder with the factory and the page size. But we can extend that configuration and actually change it to kind of suit our needs a little bit better. So to make changes to our setup, we can also provide a config instead of the page size. And we can add much more details to this configuration, such as the initial load size. This is how much data to load in the first chunk. It defaults to the 3 times of the page size. You can set the prefetch distance, as mentioned. If you've got poor network conditions or a badly designed API, you might want to load a bit more data in one go, so that when the user gets to the bottom, it prefetches a little bit more data, so you might have a better user experience. It's important to choose the right option for your architecture and your situation, but it can sometimes be quite helpful. This defaults to the page size. And then we have placeholders as well. Now, placeholders are a really interesting concept. They've been popularized quite recently, actually, to show a placeholder in place of loading content, so that the user can actually still scroll through their items, and then we don't see any kind of jerkiness of the UI with the scroll bars changing. So it's quite popular in recent apps. Might look similar to this. It's just a placeholder. So it allows for continuous scrolling. You can scroll through all your data as it's loading. Less abrupt UI changes, so the scroll bar doesn't jank. There's no kind of jumping about here. You've got scroll bars maintain consistency. And you've got accurately indicating loading states. But these come with a few drawbacks as well, or some considerations anyway. So you have like irregular sizes of these items can cause jank. So you have to make sure that each item is the same size and can be predictably drawn in this way. Otherwise, you're going to get things jumping about as they load. You have to prepare a view holder without an item. So in the binding of the adapter, you'll actually get a null value. And then you have to treat that as, well, it's going to be a placeholder because I don't have the item yet. And then it will rebind again once the item is loaded. You also have to be able to quantify your data set. So you have to know how big your data set is going to be. You can't just have like an arbitrary amount, because you'll need to know how many placeholders need to be drawn. So if your app can kind of fit these requirements, if you can facilitate that, then it makes absolute sense to use placeholders, and it's a really nice user experience. So let's go back to our config. You can use RX page list builder, as I mentioned, to return RX types. Or you can use the flow pageless builder to return a flow. The APIs are the same here. They don't actually implement the same, there isn't a common interface, but they do have the same APIs, and they're really quite straightforward to use. So jumping back to our DataSource factory, how do we retrieve one of these? How do we build one of these? Now, the best implementation, or the easiest implementation, is probably just to go ahead with Room. Now, paging and Room were sort of built together to work very well together, and then well, paging loves Room. In the code lab, a lot of the implementations are using Room, so it's very opinionated in this way, but it is actually quite a useful implementation. You might just define your DAO with a select query, and then you want this select query to sort of mirror the service you have, maybe a retrofit service or otherwise. This is really cool as well, because the Room Room library has Android tooling that makes sure that your SQL queries will compile correctly, and it'll build the data sources appropriately. So in your DEO, you just return this DataSource.factory with the integer as the key and the user as the data type. And that'll just generate the implementation for you. So it'll be quite easy to use. But we're not always using Room. Not everyone has the same implementation. Maybe you have your own database. Maybe you have your own service. It needs to be flexible enough to kind of cater for your requirements if you're not using Room. So maybe you're not using a database at all. Maybe you're just live querying data from your service. So let's say we're working with a remote data source, such as like backend service or Firebase. We need to then decide on how our remote data is indexed. So this is the kind of key component here. So then we can define the right data source to use. Now, paging provides 3 different data sources. And each of them have a variable kind of how they handle the keying on the indexing of this data. So you have a positional data source, which is ideal for like a fixed size countable set. You've got an item key data source when the items are ordered and can be identified based on the contents. And a page key items data source, which can retrieve data by page numbers. And this is actually quite common for a lot of APIs, such as GitHub and Twitter and Reddit. So let's go over these. I've got the positional data source. So, positional data source. Now you only need to provide the one parameter here for the type because it's already saying it's going to be using an int for the indexing. So it sort of assumes this, and you only have to provide one. So this is a great example of this is actually the context app because you have a list of data. They're all alphabetically ordered. It's a fixed data size, so you know how many contexts you have, and it's actually quite irregular for context to just disappear. So it allows scrolling to different particular positions. You want to be able to arbitrarily say, I want to scroll to character Z or something, or any character in this list. You're going to be able to load pages of request sizes. So you need to be able to actually then load pages from arbitrary positions, but with a requested size. It assumes the integer is a key, so it only takes one parameter. And the data should be of fixed size set, so you need to know how many is in the total, so then you can provide this data to Room and it can page appropriately. Next, you have the implementation for this. So every implementation you have, it needs to be able to provide data, so you'll have a few callbacks that you need to implement. These are like things like how much to load, also loading the initial request, and then loading every request after that. So there's usually 2 methods that you need to extend. So load initial. And you'll get different parameters in the form of configuration on how to behave on this, and then you'll need to return data from that. So with load initial, you get the requested start position, which is likely to be 0 because the user's usually starting at the beginning, but it may be a different position if the data is invalidated, and it has information necessary for the data to request. You have requested load size, and the page size, and whether placeholders are enabled. So that kind of gives you the information that you need to know if you're loading this data. And then you'll have like a load range method. So this is to load data after the initial call, and it'll be called every time the user approaches the boundary and the adapter needs to reload data. So required only to load from position X with a given size, so you have a start position and load size, and that's all you need to do for that one. So next we have the item key data source. Now this is really useful if you know, or you can identify clearly based upon the item itself what index it should be in. Now this is an example, it's a German verbs app. It's good for looking up translations. But it's very clear that you can see in each one of the words that this is A, it should be positioned here, or positioned before or after this one. So you can clearly say load items before this one or load items after this one. So like I said, great for ordered data sets. Items can be uniquely identified, so they're generally unique based upon their contents. The item key indicates position, and it has to be able to detect items before and after. So the callbacks for this one are a little bit different, but generally more or less the same. But you have to provide a key to identify each item. So that'll be a callback saying, for this item, what is the key, which you generally often can use the item itself if it's just a string. This is just so our paging library knows how to index your data. So instead, in load initial, we don't get a position index. You get a position key, which is the key that you provided from getKey. So requested initial key, the load size, and placeholders enabled. So this is whether to show placeholders as mentioned. And then after that, you get load after, which is the same as the load range from the previous one, but instead of using a key, of course, and you have the requested load size. And then you also have load before. So it's not very often this is going to happen, but if the user is then going to the bottom of the list and then going back up, or if data was invalidated, you might need to do this, but you have to implement it nonetheless. And then you have the same behavior for that one as well with the key and the requested load size. So next we have the page key data source. Sorry, finally, we have a page key data source. I couldn't find a clear example of this, but this is great for working with common APIs like GitHub and Twitter and such, because they often provide a link to the next page and the previous page, so you can sort of literally page from one to the other. So this is where you specify the key itself, and then you handle it like this. The app you're seeing here is a sample app I built for this talk, so I'll share the link for you later, but it's just a kind of opinionated implementation. So it's pretty similar to a linked list, really, because you have the kind of before and after, or previous and next items. Common for API responses, GitHub, Twitter, Reddit. The callbacks are a little bit different, so you don't really have a pointer available for load initial. I mean, you might have the circumstance where the data is invalidated, but generally the user is already at the top of the list, so it's not that important that you don't have a key here. So you just have the requested load size and whether placeholder is enabled. You also have load after, which then return the adjacent page key, which you'll get from the API of choice, and you have the requested load side, of course, and the load before, which is the previous key. Same as load after, but with a key. This is quite similar to the previous adapter as well, but it's more common for APIs. So that's quite a lot to take in, but it's really important that you understand the differences between these three items, so you can choose the right source for your application. You need to choose the right option for you, and it's based on your API structure and architecture. So you might have a situation where, depending on your situation, you might want to use the app purely with a backend. You might have multiple data sources. You might have database only. You might have backend and database. So when you're working with these things, you sort of have multiple sources of truth. So it's really important to kind of get these aligned, so you then don't pollute this data or get kind of collisions or data that should be invalidated but it's not. So if you're using a database, you generally should use it as a cache, as a kind of a backup for the live service, so then you can actually funnel data through this. Now, this is the opinionated implementation provided in the code lab and in the repository as well. So you're not actually defining the source directly, but you're actually then defining it through Room. You can use another database if you choose, but you still have to provide this data source factory. So by doing so, you're establishing a single source of truth. So you have consistent data presentation, a simple process, need more, load more, and these things are disentangled now. So rather than having a single load request that returns items, you have these two items saying, I need more data, and then that just does a fetch, and then it comes back around. Gracefully degrades on failure. So if your API is, or if you have no network connectivity, and then you can just use the local data source, and that's not going anywhere, so it's acting as a kind of a local cache. Works really well. You can optionally refresh and observe. And this is sort of achieved by using what's called the boundary callback. I mentioned this in the previous slides. Now, this sort of signals to the database that, hey, we're out of data, we need to load more. We need to load more items and populate the database. So it triggers the network load to populate, and you provide it in the PagedList builder when you're building this. The implementation looks a little bit similar to this. This is just the interface itself. But on 0 items loaded, called when the 0 items are returned from the initial load. On front loaded, when items have been loaded with the prefetch distance, and on item end loaded, it's the same, but obviously at the end. So hopefully that's an introduction. There's a lot of some more further reading. There's the talk from Florina on a similar topic. That was at, I think, Google I/O 18. And recently, I think it's droidCon in Berlin. There's also a similar talk with Yigit and Chris. This was at droidCon, I think. Sorry, Google I/O. Great talk. There's also the ADB, Android Developers Backstage episode on the prefetch and paging, where the Chet and the team talk about how they're handling and the recycler view and how this is actually implemented as well. And you've got the Android Paging Code Lab, which is sort of an introduction on the implementation of this. So a lot of the same concepts and topics that I was just talking about now. And you have the Google Samples paging with network sample. This is an implementation using Room as a primary data source, and then having the paging behavior achieved with network fetching. And finally, the Flow PagedList adapter that I mentioned from Chris Baines. This is in the TV library, TV application. And yeah, I think it was quite a nice implementation for Flow, but it's important to remember that Flow is still experimental, so use with caution. And this isn't a official option to use; it's just a suggestion. These slides are available here as well, so you can get all the links that I've just posted as well via this bit.ly link, and also the sample application that I built to demonstrate this. It's basically just fetches GitHub pages, and you can search using this query. Cool. So that's everything I've got. Thank you.